So one thing that we talked about already was the notion of a y-intercept. Okay, who can refresh my memory? What does it mean by y-intercept? Again, when the line has a y crosses a y-intercept, what does that mean? Sarah? The line crosses the y-axis, right? There's only one instance where a line will never cross the y-axis. You already think about what that instance is? What kind of line will never ever cross the y-axis? Christina? Okay, what does that line look like?
Straight.
Straight what?
It's straight. The constant.
A straight what? Like, all lines are straight.
Oh, okay.
How's it look though? How's it visually look?
Oh, okay, got it. Horizontal. No, vertical.
Yeah, vertical, right? If it's going straight up and down, right? So you got an equation like y is equal to x equals 3, right? It will never cross the y-axis, right? It will run parallel to it. Other than that, all lines will cross the y-axis. So we have a special name for that. It's the y-intercept. Yes, Steve? Well, x equals 0, which is the y-axis, yeah, so cross it at infinite amount of points. So that is the only vertical line. Correct. Okay? So all linear equations, all relations, will always cross the y-axis. So at that point, it's special because x is equal to 0. Okay? So in our equation, we set x equals 0, we get our y-intercept. So when we have the equation of a line, what did that work out to be? Remember the equation of a line? We had the equation of a line. Give me the equation of a line again. The general equation of a line that we went over. Vince? Yeah, y is equal to mx plus b. So what was the m for? Slope, right? Rate of change. Then what was the b though? Y-intercept. And that makes sense because we go mx plus b. If x is equal to 0, right, that wipes out the m, and we just get y is equal to b. So when x is 0, in other words, an independent value is set to 0, we get the y-intercept of b. Okay, so this note is reviewed. Now, think about a line that's not horizontal. So it's completely horizontal. What slope does that have? Sorry?
0.
Yeah, so 0 slope, right? The slope is 0. It's flat. 0 over the run. No. It's 0 over the rise.
Yeah.
Horizontal line.
So it's run.
So a horizontal run has an infinite run,
With no rise.
but no rise. So your rise is 0.
That's what I just said.
You said the run was 0. The run is not
No, I
0.
said it's rise over.
Oh, rise over run. Sorry, I thought you said the run is 0. Yes, rise over run so that the rise is 0. You're correct. So except for a horizontal line, it will always cross the y-axis. What other axis is it going to cross? What other point on the grid is going to cross what other axis? There's only one other axis. Yeah, it's always going to cross the x-axis as well. Okay? What's special about it when it's crossing the y-axis? Sorry, the x-axis. What's special about at that point on the line where it's crossing the x-axis? What do we know? What's special about that point? So I have a line that looks something like this. So I have a grid, right? So this is my x, my y, and I have a line that looks like this. So here we have a y-intercept. What other special thing that we see from this graph? Andrew?
I was gonna say it passes through the x. I don't know if that's like x axis.
Yeah, it crosses through the x-axis as well.
So like x intercept.
Yeah, so if you draw terminology, this is just called the x-intercept. Okay? So when we have our line, unless it's completely horizontal, it's going to cross the x-axis as well. So what's special about here at the x-intercept? what can we see here? With the x-intercept, what's special about this point here? Yeah, so y, no, it's not rocket science. Yeah, so just y is equal to 0, right? Across here, x-axis is y is equal to 0. So here we know that y is equal to 0 at this point. Okay, because it's crossing in this line, this is where y is equal to 0. Okay, so we define that as your x-intercept. So that's really just the next point. That's the only thing that we want to emphasize in addition in this next lesson is that we have the y-intercept. We understand that, we can see that clearly in the slope-intercept form, but we know that the line also crosses the x-axis. Okay, so the x-intercept is the x-coordinate of the point when the line crosses the x-axis. And here at this point, we know that y is equal to 0. And that's the definition of the x-axis, is y is equal to 0. When it crosses, where it crosses and wherever the x value is, y is equal to 0. Okay? Everybody still need this? Okay. So here, now we're given an equation. What form is this in? Well, it's actually not in form. It's not in standard form. What is the standard form? Yeah. So here we have the equation in standard form. Alright? So the question is, how do we determine the intercepts? How do we determine your x-intercepts and your y-intercepts? Well, let's work on the y-intercepts first, since we're a little bit familiar with that. So what's one way that you probably could do this is exercise in the last homework. What can you actually do with this equation? Megan? Yeah, you can isolate for y, go to y equals mx plus b, and get that b value, and that's your y-intercept. Is that pretty hard to do though? Especially if you get a weird equation, right? What we can do here is, well, when at the y-intercept at that point, what was the value of x again? X is 0, right? So as you're doing this, I want you to write this down. Be explicit about what you're doing. So here we figure out the y-intercept. Here, x is equal to 0. So all we do here is just plug in x is equal to 0. Right? We just want to know the y value when x is 0. So in order to do that, we can just plug in x equals 0 to our equation. So we got 3 times 0 is 0 minus y plus 6 is equal to 0. So here I'm going to add y to both sides. And then I get y is equal to 6. I could have minus 6, but then I left with the minus y and then I have to divide by negative. So in this case, I just added y on both sides. So here, my y-intercept is then, so the answer is a coordinated point. So what's my x value here? 0. And what's my y value then when x is 0? 6. So that is my x-intercept. Or that's my y-intercept. So here we go off and plot it, 0, 6. That's where we go across the y-axis. So we know that this line has 2 intercepts. How is it that we know that? How do we know this equation has 2 intercepts? Yeah, it has a slope. There's a y and an x, right? So if it's x equals 3, that's when we get a vertical line, x equals something. Y equals just a number, that's when we have the horizontal line. Here we have non-zero coefficients for x and y. So it's going to have two intercepts. Whereas what Leanne just said, it has a slope. So here we're going to calculate the x-intercept. So we're going to do the same thing. X-intercept. So what's special about the x-intercept? What's special about the x-intercept? What do we know for sure? Thomas?
Y equals 0.
Yeah, y is equal to 0. So here we're going to plug in y is equal to 0 in our equation. So we've got 3x minus 0 plus 6 is equal to 0. Well, the 0 goes away, so we just got the 3x plus 6 minus 6 is equal to minus 6. And then subtract 6 from both sides, because that just leaves me with 3x on one side, divided by 3. So I get x is equal to negative 2. Okay, so what is my coordinated point though? What is my point? Well, what's my x value? Yeah, negative 2. We just solved for it, right? And what's our y value? 0. Because we wanted to see what the x value was when y was 0. So we're going to plot that point. So negative 2 comma 0 is right here. Now that we have 2 points in our equation, 2 points in our linear equation, how do we know this is a linear equation to begin with again? Didn't ask that question. How do I know that this is a linear equation? What makes 3x minus y plus 6 a linear equation? Been studying linear equations now for like almost a month. What makes it linear though? I'm surprised nobody really kind of asked about this. Kind of took it for face value. But what's making that equation linear? Touched on it a little bit when we talk about nonlinear, and I gave an example. When we look at that equation, I want you to recognize when an equation is linear or not. Looking at that, how do you know it's linear? Any guesses? Would you? Okay, we'll deal with all the points, right? We're just looking at this equation. 3x minus y plus 6 equals 0. How do I know that's a linear to begin with? Anthony? Yeah. It crosses both axes, but you can have that non-linear as well. Good guess, though. Jenny? No, because we just made a standard form. You have quadratics that's equal to 0. Okay? So listen up. This is why it's linear. We're looking at two things. One, there's two variables. This case is x and y. Okay? So every equation will have two variables. But what makes it linear is that the exponent on each variable is 1 in this case. What's the exponent on each variable? Yeah, 1. The exponent on each variable is 1. And that's what makes it linear. That's all we're looking for. There's not an exponent 2 on the x. That makes it a quadratic, right? Just exponent 1 of each of the variables. So now that we know that this is a linear equation, we have 2 points. How do we get in a straight line? Just draw a line for those 2 points. So that's where you need a straight edge, right? Take out your badge, ruler, calculator. I have to take out this fancy tool over here. You make your straight line. I know. So you guys have the advantage. So we make sure when you do the straight line also have your arrowheads. As you're going to lose technical marks. You need your arrowheads on your line. And your line has to be straight. It's supposed to go through both points.
have to go all the way through the whole grid?
Just pass as much as you can. It doesn't have to flow through, but we just want it to be a little bit, somewhat long. Okay? So that's how we've done this one. Any questions on that? Any questions on the process? No? Would you?
Well, there's two ways to find out the y intercept. Is there two ways to find out the x intercept? You just have to.
No, isolating for x doesn't necessarily give you that thing. I don't know if it will give you y. Actually, no. Yeah, if you isolate for x, it does give you. So if you isolate for x, you get something times y and then a constant. If that would be your x, your x-intercept, because y 0, that gets rid of that y part, and then x equals that number. So you could do it that way as well. Good question. Okay. So here's another example. Yes, Jane?
What happens if the line is on the y? If the line is actually on the y?
So you just do it really dark. You mean the equation x equals 0?
I don't know. I'm just wondering if the line is on the y line, like in the middle, what would it be?
So your line is like this.
Yeah.
So that was your line? Yeah, so your line is just x equals 0. You just have to drop it. But that's your equation, x equals 0. Okay. So here's what you could try by yourselves. Right? So you're on your two intercepts, and then graph the relation. No, I really mean there's an actual handle for this too. What did I do with it? With these questions on there, with an actual grid. Sorry about this. Take one across the cross, please. Sorry? Okay, so we did example 1 already. Example 2 is on here. 10:55.
We're
55 minutes. Except period D. Period D is a full period.
Yay!
I know, right?
Oh, jeez.
Period.
I thought you were excited because, yeah. We at least get that. Okay, look on this question, which is question B on the handout I just gave. So again, looking for the x-intercepts. What steps do you do the x-intercept? The y-intercept? Write out those steps. So just obviously that I'm going to work on the y-intercept. And you know that that's x equals 0. And let's just start going from there. We did this. This is what I just did. Okay, so what can I? Seems like most people on the right track.
So we will zero, zero. Right? So write that down. Yeah. So that's the next step, 5 times 0 is 0. Exactly. So how does software software? How to isolate for that? Well, before we do that, we have to get minus 15, negative 15. So how are you gonna get rid of the negative 15? On both sides, right? Good. Good. Yeah.
Okay, so I'll take this up quickly because there's one other concept I want to get through. So here are the x-intercepts. So that means y is equal to 0. So we get 5x plus 3 times 0 minus 15 is equal to 0. We get 5x minus 15 is equal to 0. Basically my y term goes away. So 5x, we're going to add 15 to both sides. So minus 15 plus 15 is equal to 15. So 5x is equal to 15. Divide both sides by 5, we get x equals 3. Okay, so write down my coordinate pair, you need brackets, 3, 0. So that's my y, that's my x-intercept. So go plot this right here. And then for my y-intercept, that is x is equal to 0. So 5 times 0 plus 3y is equal to, minus 15 is equal to 0. Get 3y minus 15 is equal to 0. Okay, add 15 to both sides. So you get 3y is equal to 15. Divide both sides by 3. So you get y is equal to 5. So my coordinate point here is x value is 0, 5. What are the points? In there. And we'll just draw a straight line to that. Okay. So hopefully your line looks something like that. So now here's a different question dealing with intercepts. Now I'm giving you two intercepts, both intercepts, the x-intercept and the y-intercept. How do I calculate the equation of that line? How do I calculate the equation of this line? Well, let's step back. We've learned two forms of a line. Right? What are the two forms of a line that we've learned? Sorry, Andrea? Standard form, so where the ax plus by plus c is equal to 0. What was the other form? Slope-intercept form. Which one is most useful to us? Slope-intercept form, right? We can easily get that equation. So, let's start with that. Y is equal to mx plus b, right? If you don't know where to start, at least start with that. So to get this equation, what do we need to solve? What two variables do we need to solve for? Pooja? Yeah, m and b. You need to know the values of m and b. Well, are we given one of the values right away? Which one? Megan? B, like the y-intercept. Alright? So y is equal to mx, and b in this case is plus 4. That's our y-intercept. How do we get the slope though? Well, I can isolate, but I have nothing to isolate for.
Are you
I need to figure it out. Yeah.
4 over.
Sorry? The other form we don't even know how to get them, right? Because first of all, there's no slope. I mean, there's nothing in that form that tells us anything. That's why that form's not that great. Pooja?
Are you supposed to get an X
I'm giving the x-intercept.
though? Oh, it's not the same thing.
Well, we know it's negative 6 comma 0. Yeah. How can we find the slope to begin with? Yeah.
treat the x-intercept as a point and
Yeah.
then make it 0, I mean, negative 6, comma 0, and then sum it in.
Yeah. We have 2 points. I didn't give you the point format, but let's write it in point format. So point 1 is just take an x-intercept of negative 6. What does that really mean? Negative 6 comma 0. Point 2 is just our y-intercept. Well, what does that really mean? What's the coordinates?
0, 2,
0 comma 4.
4.
I knew you meant 4. Okay. So we have our 2 points. Once we have 2 points in our line, Megan, how do we calculate slope again? You gave me that wonderful.
Rise over.
Yeah, so m is equal to rise over run, same as delta y over delta x, which is same as y2 minus y1 over x2 minus x1. Okay? So now that we got our points, I want everyone to do this because I've seen kids mess this up just because they're just sloppy. That's all it's come down to. We got our point 1. We're just going to label this x1, y1. Right? Those are x and y values for point 1. For point 2, x2 and y2. Label them so that when you go plug into this equation, because the order is very important. Here we got y2, which is 4, minus y1, which is 0, all over x2, which is 0, minus x1, which is negative 6. Okay? It gets confusing. I will not argue that. That's why it's important. Just take that 2 seconds, label which is x1, y1, x2, y2 in your points. That way you just map it back. And here we get 4 over 0 minus negative 6 gives us a positive 6. That's the same as 2/3.
How do you know which ones? Wait, what?
It doesn't matter. And we demonstrated that before when we did slope. It doesn't matter which ones you do, point 1, point 2, as long as you're consistent here with the y2 minus y1. Okay?
Couldn't you get like a negative?
You will get negative 4 on top, but then you get a negative 6 on the bottom. Remember we did that before when we didn't matter the order, which order was point 1, point 2? The math will still work, but you get the same slope. Question there?
Yeah. Could you also just like sum the x-intercept points into the equation? Would that be easier? That's much easier.
To solve for y? Or we solve for m? Yeah, you can do that. I like doing it this way. But you can do it. Let me just write this down. So 2/3 x plus 4. So that's our equation. Okay? So the answer point was that we could have just taken one of these points, negative 6 comma 0, plug this in and solve for m. So that's a nice algebra way to do it. So that makes sense to you as well? That's an excellent way to do it. So you can plug either one of these 2 points, put an x and y, plug it into here, and then you just solve it for m. You will get the same answer. Okay? So that's how we get equation line, we just give it 2 intercepts. Finish question B for homework and also the textbook homework at the bottom.